This lecture is going to go ahead and go through Chapter 8, Designing Classes, and some important principles for it. Because of the amount of material in this chapter, we'll break it into 2 separate lectures. Concepts that we'll be covering are responsibility-driven design, coupling, cohesion, and refactoring. All of these are critical components. They operate together and independently. Software changes. Software is not like a novel that is written once and then remains unchanged. In other words, as you go through code, it gets changed over and over again. As the system grows, expands, new requirements are identified, or old requirements are changed. This is a pretty common problem. I've actually worked in shops where we had code that was over 30 years old, still being maintained today. Code from longer ago was written in a way such that people decided to maintain and update much more than today. Today, an average system might last 3 years before it's thrown out and rewritten. And it's because, in my opinion, development practices have become looser than they used to be. So don't be one of those shops. See if you can develop stuff that's able to stand the test of time. Software is extended, corrected, maintained, ported, adapted, etc. A lot of times new businesses come in, new concepts come in, and you discover new things that you have to do that you hadn't necessarily known before. The work is done by different people over time, and in many cases over decades, depending on the size of the system, the importance of the system, and if there are other commercial equivalents of it out there. Change or die. This is a pretty common opinion. Who moved my cheese shows that as well. The book. Basically, you either maintain code or you basically forget about the code and it dies a slow death. This isn't completely true, but it's true enough. Sometimes you write a base framework like a get date function, and that's not going to be maintained. It's not going to change because the whole concept of a calendar pretty much doesn't change. So there is some code that does get written once and is forgotten about, but as a rule, this is a very true statement. Software that cannot be maintained will be thrown away. 2 things about that. Code that cannot be maintained is often put over in a corner, and people eventually become afraid to touch it for fear of breaking something. They modify one thing here, 3 things over there, break, etc. And that's what you want to be mindful of. So if your Java doc and design documentation and requirements are all done properly, this is less of an issue. But if the code quality is just simply so horrible that nobody can work with it, people will do what they can to rewrite it and get rid of it as soon as possible. World of Zool is a demo that I'll go through later in a separate lecture, but let's continue. It does talk about the game, room, parser, etc., and we'll go through that again later. Code quality and design. If we're going to be critical of the code quality, we need to evaluate, or an evaluation criteria. 2 important concepts are coupling and cohesion. If you have proper coupling and proper cohesion, then chances are your code quality is higher. And you do need to have a litmus test, and it can't just be your opinion. As a rule, developers don't like other developers' code, so you need things that are non-emotional that you can put it against and be able to determine if you feel it's the right thing. So coupling. Coupling refers to links between separate units of code. If 2 classes depend closely on many details of each other, we say they're tightly coupled. We aim for loose coupling. The examples I've seen in here is when class A calls B, B calls A, or class A has to do exactly this in order to make class B work. Things like that are what you want to avoid. You want to be able to call things dynamically and not necessarily have 4 input values for 4 specific columns, because what happens if a 5th column gets added or a 6th column? Do you really want your methods to get wider and wider and wider? All of these are opinions, and you usually need to look at it and decide what the right thing is. You want to avoid circular references in your class diagram and stuff like that. Cohesion. Cohesion refers to the number and diversity of tasks that a single unit is responsible for. You want high cohesion, meaning that it does one and only one thing as a rule. Now, the hard part here is deciding what one thing is. Is one thing building a skyscraper? Is one thing building a city? Those are both just one thing, but the amount of work that goes into those is substantial. So you might want to have a house builder, a building builder, a park builder, things like that, and all of them come together into a package that's build a city. So try to limit your things to be small. The other side of this argument is if you get too small, you have something that's, build the screw, build the piece of metal, build the cylinder, build the lock. and all this gets together, that might be too modular for independent methods, or independent classes. But again, it depends on what you're trying to go for and what you're trying to do. We try to aim for high cohesion, and the unit applies to classes, methods, and modules. Okay? We want them to be single purpose and work towards a single goal as much as possible. If we were to add 2 methods to Zuul, what would it look like? What would we need to change? What methods or what things would need to happen? That's something we'll go through separately. Loose coupling. Loose coupling makes it possible to understand one class without reading the others. If you've done it well, based on the method name or the variable name or the class name, you should have a good idea what it is and what its purpose is. Therefore, loose coupling increases maintainability. Remember before we talked about you need to know the interface and not the implementation. If things have achieved loose coupling, then you know more about the interface than you do the implementation, and therefore you don't care as much about everything. We try to avoid tight coupling because one class brings a cascade of changes to other classes. While Zuul does try to make that example, you will see this where people hard code stuff all over the place, or they have constants in 6 different places, and then that one constant changes, and I got to go to 6 different places to change it. You want to try and be careful about that, because if you couple them too tightly, then you can't work in isolation and have more independence. Okay, and then flow control between objects becomes even more of a challenge. To reduce coupling, some techniques you can use is encapsulation. If you have proper encapsulation, in other words, private elements or private variables, private methods, and only those that are public need to be there, you've supported data hiding, you help achieve that goal. Responsibility-driven design supports loose coupling. In other words, if it's driven by data, enhanced by encapsulation, you start achieving responsibility-driven design. Responsibility-driven design, where should we add a new method? If your code is responsibility-driven, knowing which class to add it to should stand out fairly clearly because each class has a specific purpose. If it's unclear or uneasy to answer that, then you need to go back and reevaluate your responsibility-driven design and see if you've actually achieved it. Each class should be responsible for manipulating its own data. In other words, Class B should not manipulate the data in Class A. A should do everything for itself, no one else. The class that owns the data should be responsible for processing it as well. Manipulating, processing, variants of the same concept. Each class should be responsible for itself. If you follow RDD, you get low coupling. Localizing change. One aim of reducing coupling and responsibility design is to localize change. In other words, if I change only one spot, and a very specific spot at that, I have a higher probability of more success. When change is needed, as few classes as possible should be affected. In other words, if you've designed your code properly, then if I need to change something that is a door builder, let's say, I only have to go change the door builder in the single class that relates to doors instead of having to go change code in multiple other classes. Implicit coupling. Linkage is not necessarily expressed via data or method interactions. Sometimes it occurs because people assume things. I've seen it where you have, in order to get something done, you have to call class A, and then at the end of A it calls B, and at the end of B it calls C. That wouldn't necessarily show up in a class diagram, wouldn't necessarily show up in the method calls, but they're tightly coupled. B can't run without A, and they're basically just one long piece of code that was broken into 3 separate pieces. Satisfactory resolution might require a small increase in explicit coupling. Sometimes you have to have explicit coupling. It just logically makes sense, but not always. Cohesion. Cohesion refers to the number and diversity of tasks that a single unit is responsible for. Each unit is responsible for one single logical task. We see it as high cohesion. We aim for high cohesion, and the unit applies to classes, methods, and modules. With that, I'm going to go ahead and break this discussion into another part. Hopefully you've got something out of this discussion. If you have any questions, as always, please email me as soon as possible.